Hello everyone, welcome to our tutorial on KRUSKAL'S algorithm. If you're interested in programming, algorithms, or just love solving real-world problems, you are in the right place. KRUSKAL'S algorithm is a popular method used to find the minimum spanning tree of a graph. But what exactly is the minimum spanning tree, or MST for short? An MST is a subset of the edges in a graph that connects all the vertices together without any cycles and with the minimum possible total edge weight. In simple terms, it's the way to connect all points in a graph while minimizing the total cost. In this video, we will break down the steps of KRUSKAL'S algorithm, and I will show you on how it works, everything from sorting edges to checking for cycles. So, whether you are a beginner looking to learn about algorithms or an experienced programmer wanting to brush up on your skills, this tutorial is for you. By the end of this video, you will not only know how to implement KRUSKAL'S algorithm, but also understand its significance in finding the minimum spanning tree and solving real-world problems. Let's begin.
Here is our example graph. We have 5 vertices. We have A, we have B, we have C, D, and E. And the edges with their respective weights are as follows. We have AB with its weight 2. We have AC 15. We have BC 3. We have BD 16. We have C and D 5. We have CE 11. And we have DE 9. Now that we have our graph, let's walk through the steps of KRUSKAL'S algorithm. Step 1. Sort all the edges in non-decreasing order of their weight. The first step is to list all the edges and sort them by their weights in ascending or increasing order. Let's start. We have A and B. Okay, we have AB with its weight 2 because 2 is the smallest number in our graph. Okay. Next one is we have the vertices BC with its weight 3. Okay, let's write it. B and C equal to 3. Next number, the next number, and the vertices is C and D with its weight 5. Okay. Take note that you have to start at the smallest number. Okay, after 5 we have the next number 9. So we have to write the DE and 9. DE is equal to 9. Next number is we have number 11 with its vertices C and E. So we have to write the C and E is equal to 11. Next number we have 15, and let's write down the vertices. We have AC is equal to 15. Last number is 16, and write the vertices. BD is equal to 16. Okay, now that we finished our step 1, we already sorted the edges in an increasing order. Next is we proceed to the step 2. Iterate the sorted edges and add them to our MST if they don't form a cycle. First is we have the AB is equal to 2, right, in our sorted edges. So we write down the A and B. Okay, so let's write also its weight 2. next number is we have 3. So the vertices of minimum weight is the B and C. So we connect the B and C. And let's put its weight 3. As I have observed, it does not form any cycles. So let's continue. We have C and D. It does not form any cycle. So let's write 5. Let's proceed. We have D and E. It does not form any cycle. Let's wait 9. Let's continue. We have 11. We have to connect the C and E. But if we connect C and E, it will form a cycle. And according to KRUSKAL'S algorithm, it should not, because it might contradict the fundamental definition of a tree. There is a consequences if it forms a cycle. And there you have it. Our final minimum spanning tree consists of the edges A, B, B, C, C, D, and we have D, E. And now let's compute our cost, or the minimum cost spanning tree. Okay, so let's write the weight of its edges. You have 2, 3, 5, and 9. So to get the cost of our spanning tree, we have to add all the weight that we have in our final graph. Okay, so just add 2 plus 3 plus 5 plus 9 and equals to 19. And that is our final minimum cost spanning tree.
And there you have it. We have successfully implemented KRUSKAL'S algorithm to find the minimum spanning tree for our example graph. I hope you found this tutorial helpful and that you now have a solid understanding of how the algorithm works. To recap, we learned how to sort edges by weight, how to avoid cycles, and how to build the MST step by step. Remember, KRUSKAL'S algorithm is not just a theoretical concept. It has practical applications in network design, clustering, and more. If you enjoyed this video, please give it a thumbs up. And if you have any questions, feel free to leave a comment below. And that's it. Thank you for watching and happy coding!